Hello, everyone. Welcome back to your channel of Math Made Easy. And this series that I expect to finish today of trig, trigonometric equations. Before we start solving these types of equations, I want to draw your attention to something is that usually you say when we solve a linear equation, we get one answer. If we solve a quadratic equation, we get two answers, and so on and so forth, right? However, in the case of trig functions, you have to be very careful because, for example, if you get a value for sine. If the value is positive, it means I may have an angle in the first quadrant or the second quadrant because both satisfy a positive sign. If I get a negative sign, I may get two answers, one in the third, one in the fourth. And likewise for the cosine and the tan. So the cosine may be positive in the first and fourth. If it's negative, it may be in the second or third. So usually we can get up to two answers for sine, cosine, tan, secant, whatever. And if it's a quadratic equation, you may end up with four answers. Notice I'm talking just from 0 to 360 or from 0 to 2 pi. But if I don't give you a limit or a domain for your variable, you will have infinitely number of answers because you say, for example, if I get angle of 30 degrees, I can say 30 or 30 plus 2 pi, meaning 360, so 390, or 2 or 30 plus 720, or 30 plus 1080, or 30 plus 1440, and so on and so forth. You can add as many 2 pi's or 360s as you wish, or subtract them, and it's still going to be an answer. So there are infinitely many. That's why I said, okay, no, I want you just to look between 0 and 2 pi, or between 0 and 360 degrees. But we still may have up to four answers. And sometimes the answer may be erroneous. What do you mean by erroneous? I mean, not real. What does that mean? Suppose I solve a problem. So I made up some numbers and you solve and get cosine theta equals negative 5.2. The cosine range is between -1 and 1. So how can it be 5 point something? So we know we would reject this answer. So you have to be very careful. It's like radical equations. When you square it, you are introducing erroneous answers, and then at the end, maybe they don't satisfy, so you reject some of them. Same as for logarithmic functions. Sometimes you do some work and end up with something that is negative. Of course, there is a log of negative values, but that's imaginary, right? We are not dealing with those. So we say, no, we reject that answer. So that's why you have to be careful solving trig equations. Let's start with the first one, which should be easy. The first one tells you 2 cosine square theta minus 1 equals 0. So if we are solving for x, you add 1 to both sides, right? First. And that gives you, let me use here so we have enough space, 2 cosine square theta equals 1. And then you will divide by 2 for both sides. You get cosine square theta equals 1/2. If cosine square theta equals 1/2, and I take the square root of both sides, this would give me cosine of theta equals plus or minus 1 over square root of 2. Meaning, plus or minus, if you don't like irrational numbers in the denominator, it would be root 2 over 2. If you remember, we found that this angle exists at pi over 4, 45 degrees. But we usually report the answer in radians, okay? So theta here would be either pi over 4 because it's positive, but if I'm in the second quadrant, it would be negative, right? And I have negative. So it may be 3 pi over 4. And then you say, oh, but if it's negative in the second, it's also negative in the third, right? So you add pi over 2 again, and you get 5 pi over 4. And then you said, oh, but if it's positive in the first, it's also positive in the fourth, meaning you subtract pi over 4 from 2 pi, which is 8 pi over 4, so you end up with 7 pi over 4. All of these satisfy the fact that the square of them, you can check. Of course, let's do that. Don't take something for granted. Let me go and change the mode into radian, okay? And then say cosine pi over 4. I get the number, I'm going to square it. Of course, I get 1/2, meaning which is cosine squared equals 1/2. Okay, let's go back and make that 3 pi over 4, not pi over 4. And you can see it's the same number, but with negative. But when I square it, the negative would cancel, and I will get 0.5 again. And sure enough, you can check the rest, but it's very simple. So here, because it was square, I ended up with four solutions, four answers, I mean. Okay, four answers. Okay, let's move to the second one. I told you that would be a short session, but it's important. What if this was not theta, it was 3 theta? No problem. Why? Because I'm going to assume that this is x. Sine of x is root 3 over 2. I know if that's the case, then whatever x is, meaning 3 theta, would be, this angle is 60 degrees or pi over 3, right? But it's positive, meaning I may be in the first or second quadrants because both of them will give, I have two angles, meaning if this is the unit circle, right? I know that if I have, and let's assume I don't see the center, so they won't be exactly, but an angle of 60 degrees here, or an angle of 60 degrees there, meaning if this is 60 or that's 60, meaning this is 120 or 2 pi over 3, right? Both of them will have a sine of root 3 over 2. Notice, they didn't ask me for 3 theta, they just want theta, so I will divide both sides by 3 and get pi over 9 and 2 pi over 9. Again, you can switch that into degrees. Of course, you divide 60 by 3, it's 20. And 2 pi over 9 would be just the supplementary angle of that, which is for here it's 40, but it's either the 20 is like 160 and the 40 is like 140. So we can check even that. First of all, you can take theta as pi over 3. We know that sine of pi over 3, of course, is that which is root 3 over 2. If you multiply it by 2 and then you square it, you should get 3. So that's root 3 over 2. If you take 2 pi over 3, so sine of 2 pi over 3, it's still going to give you that, which when you multiply it by 2, you get square root of 3. So when you square it, you should get 3. So we have two answers because that was a linear function. And a linear equation gives me up to two answers. and I got two answers. Let's finish by doing the third one. So the third equation, what? That's a quadratic equation, isn't it? Yes. You can assume this is x or y or whatever variable you have, and you can work with sine, but if you are not comfortable with that, say let x equals sine theta and solve 2x squared minus 5x plus 3. Right? So you need two numbers that multiply to 6, which is 2 times 3, and add up to -5. So they must be you have to find these numbers, right? -6 and +1. I'm sorry, -2 and -3. Anyway, the way, if you don't know how to do that, which should be easy, you can use the uh, quadratic equation, or another way to do it is what? Yes, you break the -5 sine theta as -2 and -3. So you write 2 sine square theta. Why? Because I knew that the two numbers that multiply to 6 and add up to 5 must be what? Yes, -2 and -3, right? So you break that into -2 sine theta minus 3 sine theta plus 3. I'm going to combine these two and those two. So I can factor 2 sine theta, and that leaves me with sine theta here minus 1, right? But here I subtract 3. I take -3 as a factor, so that would leave me with sine theta. Be careful, I factored out the negative, so the positive becomes -1. Every time you do that, by the way, it's a good practice to multiply -3 by sine and -3 by -1 and make sure that you did it correct. Again, I have sine theta minus 1 and sine theta minus 1, so I factor them again. So I factor twice, and that's the price you do it if you don't know how to factor the original one. There is no free lunch, right? And then you open parentheses. If I factor that, that leaves me with 2 sine theta. And when I factor that, it leaves me with -3. So you see, -1 times 2 is -2, and 1 times -3 is -3. They add up to -5. But how to break it? It's easy, but again, that's how we do it, and we say this equals 0. Meaning either this equals 0 or that equals 0. If sine theta minus 1 equals 0, it means that sine of theta equals 1. Sine theta equals 1, meaning theta is pi over 2. Theta is positive in the first and second quadrant, but pi over 2 is it in the first or the second? Or both? Yeah, if you count 90 degrees from the right, you get pi over 2. If you count it from the left, you also get pi over 2. So in this case, that's a special case. We don't get two answers. Usually, if that was like pi over 4, you will get pi over 4 and 3 pi over 4. If it's pi over 3, you get pi over 3, not pi over 3 and 2 pi over 3. If it's pi over 7, you get pi over 7 and 6 pi over 7. Okay, they add up to pi because one in the first, one in the second. But if it's exactly in the middle, it's pi over 2 or pi over 2. Remember? So when you have a square equation and you get a perfect square, you don't say x equals -1 or -1. You just say x equals -1. So we say theta equals pi over 2. That's why I didn't tell you you will end up with 4 answers. I said up to 4. They may be 3, they may be 2, we don't know. But cannot be 5. Or 2 sine theta minus 3 equals 0, which means 2 sine theta, if I add 3 to both sides, equals 3. Then I divide by 2, so I get sine theta equals 3 halves. The sine cannot be more than 1, so reject it. Guess what? We ended up with the unique answer. So we expected up to 4. 2 were rejected here, right? Because I don't have it neither in the first quadrant nor in the second quadrant. So I lose 2 possible answers, or 2 possible answers, yes. And I lose a third one here. So that's a special case where you only have one answer. And that pretty much concludes what I wanted to do in trig functions. I hope it was easy. We didn't go through plotting those because I covered that in another advanced session of trig, where we introduce translations, reflections and stuff like that. I hope you enjoyed that series. It was a short one. I'm going to miss you in Trig, so maybe we'll meet in a different topic. Thank you very much for watching. Have a great day.